So to put this workshop in context, we've previously had workshops introducing programming with Python and with R. Today, we're going to be talking about software engineering. And so this is, these are things that you'll want to keep in mind, the best practices you'll want to keep in mind. It's taught by someone who, couldn't find anyone better, who is steeped in both data science and machine learning, but also has a background in actually doing good coding, which is so often the case, not the case in data science. What we find is that data scientists, I am very guilty of this, we get very scripty. And so we forget that we need to pay close attention and to write code such that it is can be shared, that we don't make common mistakes. We get so into just solving the problem. So today we wanted to take the opportunity to talk about software engineering. So if some of this doesn't make sense yet, if you're newer to programming, don't worry. You can just listen along. We're not going to be doing any coding, so there's no expectation that you get an expert in this, but listen to the lessons, listen to the ideas here. And when it's time, try to remember and to put these into practice. But let me turn this over to Dr. Sharo Bell.
All right, well, thank you for that kind introduction. I'm very pleased. But again, welcome everyone. My name is Sharo Bell, and I'm the Senior Data Scientist at Vanderbilt University, DSI. And thanks so much for joining us today to talk about software engineering, particularly as it applies to data analytics and data science. And so today's talk is going to be very interactive with the audience. So I know that I'm a very interesting person, just kidding. But I don't really just want to be talking to myself. So please feel free to respond to any questions. Please feel free to drop them in the chat. If you're wrong, right, don't worry. I just want to hear from you and your thoughts. Well, all right, let me go ahead and share my screen. Let's see, let's get the right one. There we go. Let me see where my controls are. Great. All right, so what is software engineering? Well, there's a really great definition by the IEEE Standard Glossary of Software Engineering. And they say that it is the application of a systematic, disciplined, quantifiable approach to the development, operation, and maintenance of software. So what's that again? Systematic, disciplined, quantifiable approach to development, operation, and maintenance of software. So today we're going to focus on that, but we're going to actually focus on just a subset of some of the tenets of software engineering, particularly the ones that we found really useful or essential for successful collaboration on data science projects. And I am not going to deliver a whole software engineering class to you in just 1 hour. But one thing to keep in mind is that there are some real differences between the development of software versus data science. So there are going to be some real differences in the amount of effort or the amount of weight that you apply to different trade-offs when you're focusing on software engineering versus data science. So when you're developing software, the software itself is the product. But in data science, the software or the code is really only a part of the product. So there's the actual analysis that you need to do. There's the delivered model, and then there's the operation on the data. And it has to be both maintainable and reproducible. Our code also tends to be viewed by our collaborators depending on how close they are to the modeling. And this tends to add another layer of requirements as opposed to software engineering. Regardless, the better the code is, the more readable it is, the more maintainable it is, then the easier that it is to explain it to collaborators, the easier it is to maintain it, the easier it is to extend it, and the stronger the reproducibility, as well as the better the longevity of the project. So we utilize many of the tenets of software engineering, but we may weight some tenets heavier than software engineers might, and we might weight some less than software engineers might. The last thing is that software engineering and data science actually go really great together because they're both actually designed to be iterative. So as you do your analysis using code, nothing is written in stone. You can make a commit with one code design to validate that the approach works or that the model will produce some kind of good behavior that's desirable. And then you can, in the next commit or the next commit, refactor it to make it more maintainable or more readable. Iteration really is the key to making good code while meeting the modeling objectives and timelines of your project. So let's jump in and see how we can use software engineering practices to improve our data analysis and our modeling efforts. All right, so again, what are we trying to do here? Well, first, we want the code to function correctly, right? We want to produce an accurate analysis and a good model. We want to be able to accurately measure the performance, and we want to be able to accurately answer the research questions. And we want it to be reproducible. Second, we tend to work in teams and over long periods of time. So we want to make sure that when we come back to our code 3 months later, we want to be able to understand it ourselves. But while we're working, we also want our team members to be able to understand the code, be able to review it for errors, and then make sure that anyone who comes after us is able to read and use the code as well. So maybe there's turnover or someone gets promoted or new people join the team. We want to make sure that they're able to quickly contribute and understand. Similarly to the last point, we also want ourselves and others, so our team members, people who come after us, our collaborators even, who may or may not be technical, we want them to be able to maintain and continue to develop the code. So what happens when a dependency or some package you're using updates and then your code breaks? How hard is it for you or your collaborators or whoever comes after you to understand, locate, or change that area that needs fixing? And how hard is it if you want to add or remove functionality? If you do something little, if you add a small code change, maybe if you change the structure of one of your data elements, how much does that impact your code? Does it break? And how hard is it to do? So all of these factor in to whenever you want to create code to do an analysis and to generate models. So now let's specifically talk about some of the fundamental tenets of software engineering, particularly the ones that I've found to be particularly important. Okay, so one, minimal complexity. So what does this mean? Okay, so it means that you really don't have to make these super clever designs. So if it's super clever and maybe super short and just like the most brilliant thing ever, but no one can understand it, in data science, that's not actually overly helpful. It can be really hard to maintain. It can be super hard for your teammates to understand. And if something around that area breaks, no one knows what your code does. So the thing here is that you always do have to use some level of discretion, because if you're writing some type of optimization codes, chances are it's going to be rough and it's going to be hard for people to understand in general. So of course, document that type of code as well as you can. Sometimes optimization tricks are necessary for good performance. But in general, as you're writing an analysis, it's good to make it straightforward for yourself and others to understand. Relatedly, a tenet is that you should write for humans, not for computers. So this is kind of a general restatement of the first point of minimal complexity, that you don't really need to make things harder than they should be. If people can read it, if they can read the lines and understand what you're doing, that is very helpful, particularly in data science. So it's also really good to use standard techniques. Okay, so this is particularly applicable, again, to data science. With DS work, you don't want to reinvent the wheel if you don't have to. So if you need to do analytics, you might not want to pick lists or dictionaries to be your data structure. You will pretty much end up rewriting every single function or mathematics ever. And it might also be slower because a lot of the existing functionality and the existing package are written to be optimized. Someone will also have to look at your code and parse out these huge statements of list operations and dictionary operations to even get to the point of what you even meant. So in data science, it can be really nice to use the first-class citizen packages of whatever language that you're writing in. So for example, in Python, that might be pandas, NumPy, scikit-learn, SciPy, and those types of packages. In R, that might be the tidyverse, readr, dplyr, ggplot. Another great point is reusability. So this is about designing the system so that you can reuse pieces in other systems. So to think about this, you can think about packages like pandas and the tidyverse. When you import pandas, or when you import any of the tidyverse packages, when you import matplotlib or seaborn, you're actually reusing code that's already been written. And the modularization and reusability really help to accelerate the work that you're doing. And it's understandable to lots of different people who use the packages. You can also design the same sort of behavior within your own packages. So maybe you have, or even not even your packages, but within your analysis. So maybe you just have some functions that you need to implement, and you need to apply them to lots of different models or lots of different tables or something like that. Instead of individually writing every single statement for every single table, you can make a function and reuse it. And we'll talk about how and what this looks like a little bit later. Another point is loose coupling, which relates to the last point in terms of reusability, but it is also termed modularity, meaning that you want to keep very strong dependent connections among different parts of the code to a minimum. So an example of this is global variables that are not passed into a function, but used in a function. And so whenever you're designing around this, there's a term called encapsulation. Encapsulation means that you want to keep things in a capsule of your function or your class. If it's not within that, you would want to pass it in. Another point, particularly in data science, because it's so open source, is extensibility. And what does this mean? This is the ability to enhance a system without interrupting the underlying structure. And so this comes up a lot as you're developing and adding new functionality onto your analysis and throughout the trajectory of your project. You want to be able to have your code be able to be extended, more metrics added, more model types added, more data types added. These things can really help the longevity of your code. We also care a lot, specifically in data science, about the ease of maintenance. So is this super hard to understand, or is it kind of easy to understand? Again, when something comes up, are people able to kind of track down the issue and resolve it? Or is it something when people read the code that they're so lost that they almost want to erase this and just start again? Lastly, I think I just say this on my own behalf, but maybe because I'm particularly a visual person, but in that the visual appearance reflects code logic. And so you can actually see this a lot in the actual default formatting of different development environments for your languages. So if you visually format your code in a way that it makes sense logically, then this will help people to visually be able to digest it. So you do want to format things in a standardized way and not just make some design decisions that also make it hard to maintain the code as well. So if you just start adding in a bunch of tabs and spaces, for example, in R to make maybe keywords or arguments to a function lineup, every time someone changes something like that, it's just very hard. It's hard to maintain. So, okay, so that's a lot of tenets. I tend to mentally group these things into 3 general parts. So I tend to group this into reduction. So these first 3 and kind of a little bit of 4, I tend to think of that as reduction because you want to reduce your code complexity. And in the end, it tends to make your code a little bit shorter. Now, is short code an objective that you should necessarily have? Not necessarily, but it can be very nice. But you do want to be able to reduce the code complexity if possible. The second part is reuse. So again, it's kind of exactly what the word is, being able to reuse parts of your code in other parts of the code. And again, when you're working in groups, this becomes very, very important. So everyone doesn't have their own single version of this function that's been written. Lastly, I tend to think of these last few as recycling, particularly as it comes to extensibility, because what is recycling? The ability to add or change something into something else. And we'll talk a little bit more about what this means. So let's explore this with a few examples. Okay, so let's first look at reduce. And if you haven't noticed, yes, I love recycling. Reduce, reuse, recycle. All right, so let's look at what this means. Let's take an example. So let's say for reduce, I want to read a CSV, okay? So let's take a look at one way that this might be done. So just to explain this a little bit. So this section right here actually opens a CSV file in read mode, and then it reads all the lines that are in that CSV file. After that, because now we have created a list, we need to do some operations on it to get it into a format that we can actually process. Now, keep in mind, we are doing data analysis. So now that we have things in this format, we will need to do further things with it. So this is just an example of astronomers, but what if this was a very large data frame of numerical information? So that's something to think about. So a second way that one might implement this would be instead to use a traditional package available through Python. And so this is Python code if it's not looking familiar. So this might be a second way where we import the pandas package instead, and we use the read CSV function, and we pass in just the data, the file name. And this encapsulated functionality through this package actually delivers the data frame back to us in this format. And because we have this as a class, so this is the data frame class, we by default have lots of different functionality that we can apply to this. So let's think about our tenets of software engineering that we just described. And let's fill this out together. Again, I love to talk to myself. I find myself interesting, but I don't want to do this today. So let me know your thoughts. So in terms of minimal complexity, which of these two do you find to be the least complex? Or which is the winner in terms of having minimal complexity? And I'm also going to open my chat just in case you want to put that into the chat. If I could just find that. Are people saying this way, the pandas way? All right, I agree. Would anyone like to comment on why they feel like that is less complex than this way? No one does, but that's, oh, is someone? Fewer lines, that's a great point. Also, when you come back to read this line in particular, why did I strip this line, this particular line? And what does strip do? And one might also not know what split does. So you actually have to know a lot of information about Python itself. And yes, someone said the lines themselves are very clear. I totally agree. And so like you have to know a lot about Python to understand even what this is doing. This is a list comprehension, and it's even that in itself can be very hard to understand. Here we have something that says literally read CSV. So we can read that, as well as our collaborators can read that and understand what we're doing. Love it. So we're going to go ahead. We're going to, oh, I was trying to, oh, that's the ugliest check mark ever made, but we're going to check pandas as being that one. What are your thoughts about humans, not computers? Do you think, which one wins? Pandas? I agree. I feel like this, again, we said we have this line that literally says read CSV. This one, we don't actually even know what this does on first glance unless you know it, what you have to be very well acclimated to Python. Standard techniques. So which one do you think wins in terms of standard techniques? And I would love to hear your thoughts also on why. All right, we're gonna.
You're using the. Oh, sorry.
Oh, go ahead.
I'll probably say the pandas one because you're using the package as well, which is a pretty standard method.
I love that point. Does anyone dissent? I also really agree with this. There's also a question about the word standard. So if you come from Python, you don't know anything about pandas, you might say that this is a fine way to do it because, I mean, at the end of the day, it is. It's just that when we're collaborating with each other and we're explaining things to our collaborators, it is easier to have things in this form. And Pandas is the first class citizen of data science in Python. So I'm with you here. This is a standard technique for data science in Python. Ease of maintenance. What are your thoughts there? Do we just want to put this to a vote? Let's put it to a vote. Let's see. Raw Python. No, you're, I don't even know what icons to say. No, just does someone say Pandas for ease of maintenance? I agree with you there. Does anyone want to comment on that?
I'm really lazy, and I love the idea of leaving it up to somebody else to fix read CSV if it breaks somehow.
Hard agree, hard agree. And someone will also likely find the errors in read CSV very quickly. It'll be remedied due to the very strong development team there. Totally agree. This one, if something were to break on this line, you would really have to know. You would really have to know what's going on here to break for to understand. What about visual digestibility? Which one do you find visually understandable? I'm gonna go ahead and check Pandas for that one.
Pandas.
Good. I'm gonna go ahead and check Pandas for that one. One, because someone just said it, but also because people were saying before that this is shorter. It has, you know, better readability. It's clear to collaborators. I agree with you there. All right. Sounds good. Well, let me figure out how I can clear my annotations right. Well, yeah. All right. And so now let's think a little bit more. So we have that awesomeness, right? And we've talked about specifically some tenets of software development. But now let's talk about them particularly in the context of future development and downstream decisions. Oops, there we go. All right. So let's see, let's take a vote. And actually, I am just going to, let's take a vote. So if you're thinking raw Python is the answer, do a red X. If you're thinking Pandas is the answer, do a green check. So red X, green check. Okay. Okay. So let's see. Let me bring my annotation back. All right. If you wanted to do further analysis, right, which one do you think would be easier? Red check, raw Python, or green check, or sorry, red X, raw Python, green check, Pandas? I see lots of green checks. I agree. So again, we said that this is going to come out as a data frame, whereas this is coming out as actually a list of lists. And this can be really, really difficult to work with in the future. What about easier to debug errors? Red X, raw Python, green check, Pandas. All right, I see some green checkers there. I agree with you there. If you see something in this data frame, which is also very nicely formatted, you can go ahead and look and see that there's something wrong with it. Here, in particular, you have just handwritten a read CSV. What if you have a field of text which has commas in it? Now, your parsing, which is because you split on the commas, is going to be incorrect. This has already been taken care of in read CSV. So there's a lot going on there, and I think this makes it easier to debug any errors that you come up with. What about easier for your team to review? So we like to do pull requests, and we like to have other people to review the code. Which one do you think people would have an easier time reviewing? Raw Python, red X, Pandas, green check. All right, it looks like the green checks have it. I'm with you because all you need to do is read this. What about easier to remember code choices? So for example, this doesn't actually really have any code choices, but they are available by different keywords that you can add here. What about here? Which one do you, because apparently I added this strip in this split. What happens when I don't remember why I did that? So for which one do you think is it easier to remember code choices? Red X, raw Python, green check, Pandas. All right, I think the Pandas way has it. And so I So this is an aspect of reduction. We want to make things the least complex that they can be given the skill level of our team. And we also want things to be very readable and maintainable. And so this is an example of why you might want to stick with the standard package. Now, it's not that the standard package is always just like this best, wonderful thing ever, but in this case, and in many cases, it often is. All right, fantastic. So let me clear those drawings. And let's go on to discuss what, let's try to get to that next slide. Let's talk about reuse. So let's take another example. And again, we're discussing reuse, what it's like to reuse code. So let's take a first example where we have some confusion matrix and we have decided that we need to calculate the sensitivity, right? So actually, I think scikit-learn likes to return you confusion matrices like this, right? I think they're NumPy arrays, though they're not just like full list, but that's neither here nor there. And so someone decides, okay, well, I'm just going to calculate the sensitivity by calculating sensitivity, but I'm going to do it individually for each one of these. And for every single one of my results for my experiments, I'm going to write it out. And then I'm going to print every single one individually out. So this is definitely a way that you can do it. Let's look at another approach. So here's another way. So we have the same results, and this is a confusion matrix, except for now we've used this function, we've created this function called calculate sensitivity. We're able to pass in particular parameters. You can see here that we actually do the exact same calculation as we had before. And we do the exact same printing that we had before. And we're able to get the value back just like we did before. And here we just call the function by passing in these different values, and we're able to achieve the same results. So now going back to our tenets of software engineering, let's think about the behavior and which one seems to be more agreeable for the software engineering practices. All right, so back to annotation here. If only my computer would work with me. All right, which one do you find to be less complex? Red X, this method 1, green check, method 2. Ooh, some people find this one to be less complex, and some people find this one to be less complex. Ooh, I love dissent. Okay, so it looks like the method 2 people have it, which is interesting and something I agree with. But I can also see why someone would say that this is actually less complex. So if someone is writing code, maybe for, just starting out, having this written just directly and to the point of exactly what's happening can actually feel a lot less complex. So I understand why that would be an answer as well. So let's just make a little small check. Okay, we're just gonna have a little small check there because, it just depends. All right, let's talk about standard techniques. Red X for method 1, green check for method 2. If you're ambivalent, maybe just put up a different icon. Or if they seem to be the same, just put up a different icon other than a red check. All right, so we feel that method 2 tends to have the more standard techniques. So I agree with you there. So just using functions is very familiar. It is standard, but I would also argue that this one is also, it's pretty standard itself. So I would have to double check this one. Ease of maintenance. Interesting. Which of these do you find to be more maintainable? And you can just give me an answer because we're actually discuss this at length in just a moment. So which do you find to be more maintainable? Red X, method 1, green check, method 2. I'm with you there. And again, we'll talk about why this might be more maintainable than this one. Visual digestibility. Which one do you feel is easier to look at and in looking at, understand? Method 1, red X, method 2, green check. All right, people feel like this one is more visually digestible. I both agree and disagree, so I'm just gonna little small check here. So there is some merit to this one because it just laid right out exactly what's happening. But this one has, it's still, digestive. You know, you still have this and this. It's just that you have this function intermitting. So I think they're both just fine. Extensibility, and again, we'll come back to exactly what's meant by this in a moment, but which of these you feel is more extensible? So when I want to add more functionality, which one do you think that it's easier to add more functionality to? Method 2, green check. Method 1, red X. All right, we have a really heavy weighting on this method 2, and I completely agree. And let's get into why that might be. All right, so taking a look, we could just get on to the next slide. Let's talk about maintenance and extensibility for our team data science project. Okay. So let's talk about this. So this is 2. So this first one here, this is 2 experiments. This is also 2 experiments, right? What if I wanted to add 30 experiments? Would it be easier to add 30 experiments here in method 1 or 30 experiments here in method 2? All right, it looks like the green checks have it. So I have to agree with method 2. In the end, you will still have to write 30 of these statements here, so there may yet even be a better approach. But for this one, there is a lot more correction of copying and paste, right? So we have since 1, since 2, XP1, XP2, here, 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 and here. In fact, I caught an error for myself that I forgot to fix a copy paste, okay? So this is very, very error prone if we wanted to add 30. This one, a little less error prone, but still some challenges here. Again, there's probably a better approach, and there is, at least using a list to help us as well. All right, so let's just build on that. Let's add even more difficulty, right? So now we have our 30 experiments, right? Now I look at this value and I say, wow, that's a lot of numbers there. I would like to round that. And the way that you can do that is just using a round function on either like lines that look like this or this line. Now, which one do you think is easier for my 30 experiments here to add rounding to? And if you can, put in the chat why you think it's easier to do rounding on my 30 experiments in this method versus this method. Green check, method 2, red X, method 1. All right, it looks like the method 2s have it. Does anyone want to say why or what might be the challenge here in terms of adding rounding? Absolutely. Nice job, Adam. So here, you actually only have to add the rounding functionality to literally this line, or you can do it here. You have to add it to this one line. Here, you would have to write it for literally all 30 lines. Nice job. Good job. All right, ease of extending functionality. So here, this is calculate sensitivity, but maybe what I want would be calculate confusion metrics. So like sensitivity, specificity, positive predictive value, negative predictive value. Maybe I want to calculate all of those for each experiment. Which one of these do you think it would be easier to add that function to? Or which one of these do you think it would be easier to modify to accommodate that functionality, again, for 30 experiments? Thoughts? Red X, method 1. Green check, method 2. If you have thoughts about why, stick it in the chat. All right, it looks like green checks have it. I'll wait a second for the chat to see why. Or you can feel free to unmute.
In your function, you could add in other metrics apart from just sensitivity. I feel like that's going to be a lot easier than having to create a new statement and run that.
Exactly. That is such a great point. So here you could actually just like change this function from calculate sensitivity to calculate confusion matrix metrics, and then just write the functionality here and then just return that. Here, for every single experiment, you would have to add every single metric that you wanted to compute. So that is just making your code very, very long and terrible in terms of maintaining. Because now if you want to add even one more metric, maybe if you calculated one wrong, you have to go back and change all of that. So functions, they can be your friend. You put it there one time and you use it a bunch. Reuse. Now let's take this last moment and talk about standardization. Okay, so with these three, you can think about working alone. But now let's think about working in groups. Okay, so let's say it's you and 5 other people. Each of you is doing a similar analysis, but on different experiments and different models. Now you say that you want to compare the performance, but you've all written it as just some method, and there are no functions shared between you. So for example, so you all wrote it in this method, you wrote it just like this, and you don't have any common of these. So for example, one person might have defined the target class. So again, sensitivity. Sensitivity requires a target class, right? So maybe person 1 defined the target class one way, person 2 defined it another way, person 3 used a different naming system, person 4 used a different metric, person 5 didn't even use this. So is it easier to bring those differences into alignment or eliminate the differences altogether by pre-planning with method 1 or with method 2? All right, I think the method 2s have it. And why is this? Because once you decide, so if you plan out your code, which tends to actually happen in software engineering, you get together and you plan it, what you're going to do. You can decide what functions exactly it is that need to be written. If there's 5 of you, 5 metrics, each of you can write one and then come back and use the functions made by other people to do all of the analysis as well. So not only is it actually standardizing across all of the experiments and all of your models, it's also taking a divide and conquer approach, which can help you to optimize the time if you're on short timetables or you just want to do a lot. Nice work. You guys are really good at this. So this was reuse. And so we're able to reuse, again, in a lot of different ways. In one single notebook or one single analysis, we can do this over a bunch of different experiments. We can easily extend functionality, but over different people, we can also share this functionality and standardize the functionality across everyone. And these two things are very powerful in data science, especially when you're on teams. All right, let's take another example. Wow, this is getting towards the end of my time here. Let's take another example that we're going to go through actually pretty quick. Let's talk another example of reuse. Okay, and now we're going to actually focus on something called coupling. And what we want is loose coupling. So for example, let's say that we have some serial numbers, right? This is just a list of serial numbers. And maybe there's some character in here that we just don't want for whatever reason. So we identify it here. Then we say to ourselves, okay, we're going to do this reuse thing. Super great. We're writing a function. All my team members can use it. I can use it. It's understandable. Great. So we write our function. We're going to pass in a list. And from that list, we're going to call the replace function. Again, a standard function of Python. We're going to pass in the character that we want to drop, and we're going to replace it with the empty character. And then we're going to do that for all of the characters, right? So interesting here. This is a variable here. We actually haven't passed it in, but we're using it here. Now, does this work? Yes, it does. Great. So that seems to be working. Okay, so this is method 1. There's another method that one could do instead, right? So someone else decides to implement it like this. And so here we have the same serial numbers. We have the same drop character. Okay. We have a similar function. But now what we've done is we've passed in a parameter for what we want to drop, right? And so here we use that passed in parameter to drop it. And so you can see here in our function call, we are able to pass in specifically the thing that we want to drop. So take a minute and mentally digest this. If you came to the NBDev workshop, you would know that if we wanted to export just this function, it would essentially take this out of the notebook and place it into a Python file alone, right? Where we have this variable called drop char, which is literally defined nowhere else. On the other hand, we could also do the same thing here, and we could export this function alone. And this is actually a encapsulated function, meaning that everything that we need is present in this function call, like in the actual parameter list or in the function itself. So let's talk about that. Okay. So now using the tenets of software engineering, let's rate these. So I'm actually just going to give you a second to just really think about the behavior of this one versus the behavior of this one. In fact, how you can think about it is if you were to run this alone, would it generate an error? Would it even run? Okay. All right, so I'm going to pause for a couple seconds. All right, so now let's talk about it. So in terms of loose coupling, again, that means that there's something in your, like in your functions, they're kind of separated from everything else. So would you say that this method 1 has better loose coupling, or this method 2 has better loose coupling? Red X, green check.
And I have a quick question about loose coupling. Does that mean, as you're just suggesting, it'd be easier to sort of pull that function out, still have it work? Is that loose coupling?
Yeah, it just means that there's not like the relationship between parts of your code is not so tight that you couldn't really take the whole piece out and use it on your own. You tend to like to have them loosely coupled so that if you were to change one thing, like you can flexibly change one thing without destroying something else.
Thank you.
Loose coupling thoughts? Oh, we have some responses. So green check. So I'm going to go with people who voted for method 2. And it is loose coupling. In fact, this is extremely tight coupling. This function actually will not work on its own unless you also provide this. So this is the tightest coupling. This cannot work without this. This one instead, this can work. This can work on its own. All you need to do is pass in the things that you want to operate on, and it will return you exactly what you want. So also let's talk about this then in terms of reusability, particularly this function, because again, this is Python. We tend to like to use IndieDev. And so we might want to export this function alone or this function alone. Also, because we might want to define a different character to drop. So we define this @ symbol, right? But maybe we want to drop the pound sign. So which one of these do you think is more reusable? Green check, method 2, red X, method 1. All right, I'm with you for method 2, because actually on its own, this function isn't reusable because it won't even compile correctly. Not compile, but execute correctly. Because alone, it has no idea what this character drop char is. That no one knows what that is. Here, it doesn't have to know. It doesn't have to know because it's using the parameter that you pass in. So the last thing I'll say about this is it's not like this is extremely suboptimal, but this is not something that could possibly just be broken on its own. You would have to look into the code and see that you need something defined as drop char and then define it before you import this functionality. Now, does that sound maintainable? Does that even sound like a good workflow? Does that sound like a good life that you're about to have? No. So this is the way that you probably want to do this, using the software engineering principles of loose coupling and reusability to implement reuse. So again, loose coupling, this is tightly coupled because this cannot function without this. This one is extremely loosely coupled from the rest of the code because it can function on its own. All right, moving right along. So now let's talk about recycling. So what again do I mean by recycling? I mean taking something that is in some form and modifying it to a certain purpose. Okay, so That is a scary statement a little bit, because that sounds like bending something to your will as opposed to using it as it should be used, okay? But that doesn't necessarily have to be how it is. So this recycling tends to come up a lot when you are doing more software development activities. So if you're trying to develop an analysis package, so if you're going to be like developing like Pandas or Fast.ai, and it kind of tends to come up a little bit less during analytical and modeling behaviors, but there are certain ways that it does come up. And so let's talk about them, okay? So here's an example, right? This is a little bit complex. This is in R. It's a little bit complex, so don't worry if you don't completely understand. But the objective is this is to allow flexible loading through authentication. Okay, so that sounds like crazy talk, but the basic story is that if you're going to read through from some foreign box, you actually need to call a different type of function on an Excel file. Specifically, you need to call this function to be able to read a regular Excel file from box if you're using authentication. So what is this? Okay. So in R, what this is doing is we're recycling this read Excel function, right? How are we recycling it? What we're doing is we're passing actually the exact same parameters that we would pass to read Excel into this function, right? Because read Excel wants the file path, and it can also accept other things to tune it, or make it more flexible for what you actually need, right? So if you just have a regular function and you have your regular CSV or Excel files directly on your computer, this might be a great way to do it. But maybe you're working with someone who actually uses box. So if you wanted to use the same function read Excel, what could you do? Well, you can still have this uniform interface of read Excel. You can still use this function read Excel, but instead you would use this box read functionality, and you would use slightly different parameters. So you would need to read from the FID, right? So this is just a file ID from box. But then you could still again recycle, because you can use the read Excel function to read the same file path with the same parameters. So this can be really, really nice. And I think this is a pretty good use of recycling. But the only point that might just have a little consternation is just the overloading of this function. So now you actually have created this sort of conflict where you have masked the behavior of read Excel with your functionality, except for in the end, it still does use the exact same functionality that you want. So this is just a little bit of recycling behavior to help you collaborate across other people. All right. So what are some examples of how recycling tends to show up in analytics tasks? Well, just like this, because this is really more of a overload, override kind of behavior, but it shows up in terms of wrappers, which is also in Python, you hear about things called decorators and partials. Those are just ways to recycle some existing functionality into specific things that you need. And these are actually provided through the Python, by Python. So these are acceptable ways to be able to recycle the code that you have. So let's quickly look at another example. So what you're looking at here is actually pandas and the implementation of data frames. And as you can see here, you have this thing called ND frame, which, do we know what that is? Not really. We don't know what that is. We're not used to using that, but we can see that it inherits the behavior from two other types of classes. What does that mean? It doesn't matter if you don't understand that. It basically just means, just like I have parents and I inherited some of their genes, ND frame inherits some of the genes from pandas objects and from this thing, right? And so the data frame class that you see actually inherits also from ND frame. So this is a very strong use of recycling, but again, you tend to see this a lot more when you're actually developing the package as opposed to when you are doing yourself the analytics and modeling, okay? So if you would like to learn more about this, the specific terms that you would want to be looking for are things like inheritance. So I really just talked about inheritance of genetics. Polymorphism, which means that a single thing can take on a lot of different behaviors. And then abstraction, meaning that you have, it's very related to inheritance, meaning that you define something that's relatively abstract and then you make it more specific through using derived classes or children classes. Okay. So this are some example of recycling. Again, within analytics, if you're working across many, many people, it tends to be sometimes that you need to do things like this. And so you tend to use wrappers, decorators, partials, principles such as overloading and overriding to recycle code that you already have. And if you're actually doing real software like development, you do tend to use a lot of the more object-oriented frameworks. Oops, let me clear my drawings. So just to answer a few questions that you might have that have come up in the past for me. Let's see if I could just, okay. So when should you turn your code into a function? So this kind of depends on your skill level. We said before that if you're really, you're just dipping your toe into data science and dipping your toe into coding, write it how you understand it. Sometimes the point is that the thing needs to get implemented, write it how you understand it. And as soon as you can, go back and refactor it. As I said before, data science, software engineering, these are iterative activities. And so you can always go back and make things better. When should you turn code into a class? So this is a very strong question. Also to just expand upon this last statement here. So if you find yourself copying and pasting 1,000 times, that's when you know that you need a function instead of this thing that you copied and pasted 1,000 times. There's kind of a similar principle to when you should turn code into a class. But again, this is getting into more of the development-y things, and it comes up a lot less in like pure analytics. But if you find that you have a bunch of related functions and in particular data elements that all kind of go together, and it would be easier for them to be considered as a group rather than as just individual things floating around the code, that is when you should be thinking about making it into a class. But if that's not something that's overwhelmingly important or it doesn't provide a lot of different clarification for your work, then maybe focus on the data analysis and the modeling portions. What should I comment? So what line should I comment? Should I comment every single line? Does every line need a comment? So this also depends a lot on your team's skill level as well as the level of involvement by your collaborator. In general, I just say, if it's code that's very difficult, comment more. If it's just a general code block, comment less. There's also a question is what is meant by complexity. So we talked about minimal complexity, right? So code can be complex due to unfamiliar packages. So say for instance that the person has no idea how to use pandas whatsoever. Team members have no idea how to use pandas and they don't use pandas. They actually might find the use of pandas to be more complex than if they were to write all that functionality out in Python code. And that has happened in the past. So in those cases, I do say like you will want to use the standard techniques, because when it comes to maintainability, it'll come back and something will break and you will not be able to understand where it is, particularly in Jupyter notebooks. So, we like to use literate programming practices in data science. Jupyter notebooks are a big part of that. And so when you have very complex code that is like for loop, nested in for loop, and for loop, that could be a challenge to debug, especially because you can't run it line by line. Let's see. One that comes up big time. I'm on a tight deadline and I just need to get the analysis done. How should I get these principles? How should I integrate these principles, if at all? So as much as you are able, you should try to integrate these principles. If you want to deliver a model, or you want to deliver an analysis, you should try to do that. And your skill level will dictate the amount of adherence to the principles that you can. It's just that, like I said, things come back. So, the next time you go and look at something, or the next time you pass your work on to someone else and they try to use it, if it's not maintainable, if it's not understandable, they might just throw it in the garbage and just start all over, which would not make sense and wouldn't be good for anybody. So do try to use good software practices, software engineering practices. Oops. All right, let's see. So all those questions basically turn into the question of how do you balance certain trade-offs? So time versus readability, maintainability, complexity in terms of packages complexity in terms of skill levels? How much should I comment? These are all just a balancing act of trade-offs, and they're really very much dependent on your project requirements, the skill level of your team, and the expected use case. So is your collaborator going to be looking at it? Are you going to be creating it into a package? What is going to be the use of it? Some last questions. I'm working with other people on a data science project. How do we apply these principles? Kind of as described, if you're working with other people on a data science project, these principles are paramount. Sharing functions between each other, very, very important because it'll standardize the approach. You don't have a bunch of different results on different pages that can make no sense to anyone. So these are really, really important for team-based work. Lastly, if you're just working on your own and you're not building a package, but you're doing a research paper, do you need to embrace these principles? So I would strongly say yes, mostly because when you're on the research paper, then you get the question of reproducibility. And also you have the question of sharing your code so that other people can inspect it and just be able to understand what you've written in your research paper. So I would argue that it is extremely important in that case as well. All right, so we're coming up on the end of our time, but just a few other suggestions that I have. Always use a GitHub repository. It'll make your life a lot easier. If you're working on a team, use pull requests and review each other's pull requests. Also decide on a shared repository structure. So sometimes that can really help with code sharing and being able to use functionality across the team members. Always use literate programming practices, so use your markdown as much as you can. Write doc strings for your functions. This is particularly great in Python, where you're able to use that contextual help. When you forget the input parameters of your own functions that you've written, they'll pop up and it'll remind you about what you can pass in and what you can't, and also the data types in which you can operate on. Again, you're going to want to comment your code sections or any some in general code sections, or if there are areas that are particularly difficult, you might want to comment them more line by line-ish. Do add in time for refactoring if you can. If you're on a super tight deadline, I understand, but it is good to always go back and review your code, but this could also take place during your pull request reviews. Just general advice for beginners. If you don't have any idea what to write whatsoever, just start writing comments. Write the steps out for yourself about what you need to do, and take those comments and translate that into code. Lastly, try not to have repeated code. So you don't really want to have the same set of code in two different places. Once you modify one, that means you have to also go back and modify the other. It tends to be nice if that's either done automatically or using a package which makes sure that those two things are in line. And NVDev in Python is a great example of when you can have the same code that is repeated, but it does manage that they are exactly the same. Just some literal last advice. I know I'm over my time here, but I would just suggest that you learn the capabilities and limitations of your tools. This has come back to really haunt me about, if you just didn't know enough about the tool that you were using, it'll help you to wield it correctly if you know what it can and can't do. And also don't try to bin code or platforms or frameworks and force it to work for you. So the example I always give is with Python and R. I learned how to program in Python and MATLAB and C and C++. When I started using the tidyverse, I tried to bend it and it was awful. So do try to actually investigate and understand the underlying paradigms of any opinionated framework and use the framework according to the opinion. Some few last words. If you're inexperienced, start small, build up. It's okay, you don't have to know everything from the beginning. Do spend time in source code. If you have some packages that you really like, so for example, Fast.ai, Pandas, spend some time at it and see what they're doing. It'll help you learn how to become a better programmer. A second thing is to review pull requests. This is actually one of my favorite activities because I love to learn the different approaches and thoughts that people have when they're writing code. You find a lot of tips and tricks and you learn a lot of different things. And it's also good for the person whose code is being reviewed. If you don't know everything from the beginning, don't worry. With experience comes skill. So the more you work at it, the better you'll get at it. That's all I had today. If you have any questions, please feel free to reach out to me, email, Slack. I can stick around for a few minutes for questions. And sorry we went over a little bit, but thank you so much for coming, and I hope that you found this to be helpful.